you our last project right now, which is a COVID model. So the way it works, I like to show you the end project at the beginning. So what you're going to end up with. So the way this works is it's going to launch 200 little dots. And some of the dots are sick at the start and they can get sick. So first we'll just play with these variables. So sick at start is 0. So if I hit this, I'm going to end up with 200 healthy little dots and they're all going to bounce around. Okay, so that's the first thing it does. Now the next thing it does is I can say, hey, I want to have a certain number of them sick at the very start. So if I set it to 100, that means half the dots will be sick at the very start of it. Okay, so let's go ahead and take a look at what that looks like. And you can see that half the dots are going to be red and then some blue dots are going to show up. All right, so half the dots are sick to begin with. The other variables that I have are things like speed. So speed, if you think about it, speed is very similar to whether or not people wear a mask or whether people are staying at home, stuff like that. So if I set speed really high and I run this thing, you're going to see the dots are going to start just flying around. And it means that everybody is going out and hanging out with each other. It's like the situation is as normal as possible. There are a few other variables I have too, which is the infection percentage. What this means is how likely you are to get sick if you're healthy and you touch a sick dot. So for the common cold, for example, if you're around somebody who has a common cold, maybe you have a 10% chance of getting sick. And if you're around somebody who has Ebola, which is a very dangerous disease, you have like a 90% chance of getting sick. So let's see what happens if I say, okay, I want 20 dots to start sick. I want everyone to be moving around like crazy, but I want the infection rate to be 90. Recovery time is, in this model, the way it works is after a certain number of seconds, you get better. So in this case, I say after 50 seconds of being sick, you recover. So let's see what happens. I predict that pretty much everybody will be sick very, very soon because the infection rate is 90 and everyone's moving around. And you can sort of see that basically everybody is sick. In fact, all of them are sick for sure. All right, so let's go ahead and set up a different kind of scenario. And this is what an epidemiologist might do to determine how a population is going to respond to illness. So let's assume that people stay home a lot. So I'm going to make them move really slowly. I'm going to set my infection rate at 50%. And I'm going to say, instead of taking 10 seconds or 50 seconds to get better, I'm going to set it to 10 seconds to get better. There's still 20 little dots sick at the start. Let's see how my population does now. Okay, I've got my 20 dots. Now what we're going to see is we're going to see a lot of people recovering because after 10 seconds you get better. And there's only a 50% chance of getting sick if you're touching a, if you're healthy and you're touching a sick dot. So let's see what happens. I have a feeling that my population is still going to be pretty darn sick because even though people have slowed down, it's not like I've got people staying at home. If I want people to suddenly start staying at home, I think I can change this. Yep, now everyone's staying at home. It's like we've gone into COVID lockdown and everyone's going to get better because after 10 seconds, everyone is going to recover. So now that everyone's recovered, I can move around my population again and nobody's going to get sick since nobody is sick. So what we're going to be doing is we're going to be building this model, and I'm going to show you how to build this from start to finish. And then I'm going to really encourage you to play with some of the assumptions you're making to see if you can make the disease happen or not happen. In this case, I'm going to move people really fast. So they're going to be moving around like crazy, but the infection rate is only 10%. Let's see what happens. I have a feeling that everyone's going to be sick because it's just too much interaction. You're too likely to get sick from somebody else because you're moving so much. Yeah, this is a pretty sick population right here. A lot of red dots. So if I want this population to become healthy, I better have them start wearing masks or have them interact with each other less. So I'm going to move it to 50. Let's see if that helps. Probably still a little bit too much interaction, even at 10% infection rate. Remember, the recovery time is 10 seconds, so it takes a little while to kick in here. I'm waiting 10 seconds. I'm waiting 10 seconds. Well, it looks like we still have a lot of sick dots. So let's slow everybody down. Just stop interacting with each other so much, people. Stop going to concerts. Stop going to the movies. Wear masks. Is this going to be a less sick population? Yes, it looks like this population is less sick, for sure. Still, we've got some illness here, and I don't think we'll be able to actually stamp out all the illness until we slow things down even further. Well, maybe I'm wrong. We've only got, oh, wait. We've only got 2 sick dots right now, and there's our last sick dot. So by slowing that down and having our infection rate at 10%, so maybe this is, the infection rate would go down if people were vaccinated, for example, we are changing our COVID model. So this is what you're going to be building for our last project.